Hello everyone, this is the first lesson recording for IM2 October 8th, 2020. Let's begin with some announcements. So you took quiz number 3 last Monday. Well, some of you have come to me to take the retake. 3 students have done so and they have all improved their scores significantly. And that could be you too. So if you want to improve your grade and your learning, then please come see me, contact me to arrange time to meet to go over your quiz and then retake the quiz the next following day. Some of you might be thinking, oh, you know what, the quiz is already done, I'm just gonna try to do better next time. Well, if you didn't do well on the quiz, that means there's some misconceptions or some holes in your understanding, and the same material is going to be tested. We are going to be testing you on the same material on the unit test as well as semester final. That means we're going to keep hitting you with the same material, okay? The sooner you take care of that misconception or any holes, then you're going to do far better. So please take advantage of the retake opportunity. Some of you might be thinking, I don't want to take the retake because I might actually score lower, okay? And I don't want my grade to go down. Well, that's not going to happen, because even if you score lower on the retake, then the original score, that's the highest score, will be kept in your grade. Okay, so you really have nothing to lose. So if you're willing to put in a little bit more time and effort, then hopefully you are not only going to improve your grade, but really improve your learning so that you're going to do far better on the unit test as well as semester final. Okay, let's get started with the day. What are we doing today? We're going to start by reviewing fractions, because we're going to be dealing with fractions more, and how dilation relates to similarity. So equivalent fractions, what are they? Equivalent fractions are two fractions that represent the same quantity. So if you have this diagram, you have a whole being divided into 5 pieces, and out of that you have 3 shaded, so that's 3/5. And if I have another diagram with the same amount shaded, but this time the whole is divided into 10 parts, and out of that I have 6 parts shaded, so this is 6/10. And we say, because they are really talking about the same amount being shaded, okay, this pink part and this pink part is really exactly the same amount, we say they are equivalent fractions. And how do we get from 3/5 to 6/10? We multiply the 3/5 by 2/2. Why did we do that? To get the denominator to be the same. So to get the denominator of 5 to become 10, we multiply 5 by 2. And whatever I do to the bottom number, I need to do to the top. So if I multiply the top number, the numerator, by 2, that becomes 6. And why are we allowed to do this? That's because what you have here is 2/2, which is just my giant 1. Okay, if you remember your giant 1 from IM1, you're basically multiplying a number by 1. And you're allowed to do that because any number multiplied by 1, you are not changing the value. Say 253 multiplied by 1 is 253. Any number, it does not matter. Okay, so then let's go on. Okay, what about this picture? This time we have 3 parts out of the 8 parts shaded, so that's 3/8. And this is 6 parts shaded out of the total of 16. So this is 6/16. And how did we get from 3/8 to 6/16? We multiply both the numerator and denominator by 2/2, which is my giant 1, and got there. Okay? So now we're going to try to go backwards. Now we're going to try simplifying. Okay? If you have 20/28, what is the simplified version of this fraction? That means we want the 20 and 28/28 to be smaller, both of them to be smaller if possible. Okay, how do we do that? Well, you need to look for equivalent fraction such that there are no more common multiplier in numerator and denominator. So the hint is to start with small multiplier like 2 or 3. So that means if you have 20 over 28, okay, I need to be thinking about, okay, what is the number that is divisible by both 20 and 28? Well, because they are even, I know at the very least, I know they are both divisible by 2. So that just becomes 20 is really the same as 2 times 10, and 28 is really the same as 2 times 24 or 14. Okay? But I still have another 10 and 14, and I know that they are still even. That means I can do that one more time. So 2 over, this is from before. Now we're going to divide 10 by 2. 10 is really the same as 2 times 5, and 14 is same as 2 times 7. Okay? And now here is my giant one. So I can just cancel this out. 2 over 2 is just 1. And 2 over 2 is just 1. And you are now left with 5 over 7. So I know that 20 over 28 is same as equivalent to 5 over 7. Okay? Alright, so then I want you to try this yourself. Okay? I want you to try to simplify this fraction to its equivalent fraction. What is the common multiplier that exists in both numerator and denominator? And simplify. Please pause the video and do that now. Okay, I hope you've had a chance. When I look at 15 and 24, well, they're not even. That means 2 is not going to be helpful for us. So let's try 3. Is 15 divisible by 3? Yes, because it's 3 times 5. Is 24 divisible by 3? Yes. Okay, so that means this is same, 15 is same as, okay, actually I have a slide. It's same as 5 times 3, and 24 is same as 8 times 3. So then here is my giant one, which cancels away, and so you're left with 5 over 8. Okay. Alright, try another one. What's the common multiplier that exists in both numerator and denominator? Please pause the video and try it now. The answer is, here we go. 48, I can divide both of them by 2 because they're both even. So that becomes 24 times 2 and 10 times 2. It's still 24 and 10, they're both still even, so then I can do that one more time. And that becomes 12 times 2 times 2. And 5 times 2 times 2, and so you are left with 12 over 5 as its most simplified version. I know that 12 and 5, there are no more common multiplier. Okay, so and it is much easier to see that there are no more common multiplier when the numbers are smaller, right? So make sure you try to reduce them as much as possible by dividing into 2s and 3s, maybe even 5s or even 7s, depending on the number. Okay, all right, so now let's get on to solving ratio equations. So if you have these two fractions being equal to each other, we actually say that ratio is a fraction, or another word for fraction, that relates how two numbers are related. And then when you have two ratios being equal, we say this is a proportion. So you have an equation x over 7 is equal to 11 over 4. Okay, some of you are just so used to just cross multiplying without really understanding why. That's why I'm not really a fan of cross multiplying unless you understand. It's a very powerful tool if you understand why it works. But many of you just do it mechanically without understanding, and then you end up doing it all over the place where you're really not supposed to be doing. Okay, so I am just going to do it, not the cross multiplying, but this is just one step equation. Okay, so x is being divided by 7. So x is being divided by 7 is equal to 11 over 4. So I really just want to get to x is equal to something. That's what solving is. So what I want to do is I want to get rid of this 7. How can I get rid of this divide by 7? Well, to undo divide by 7, I need to multiply both sides by 7 because division and multiplication, they are inverse operations. Okay, and this 7 divided by 7, they are really my giant 1, and so they cancel out to become 1, and then you are left with x is equal to 11 times 7 divided by 4. Okay, remember when you're multiplying fractions, this 7 is really same as 7 over 1. When you multiply fractions, you always multiply across with top and then bottom with bottom. So it's 7 times 11 is 77. Divided by 4 times 1 is 4. Okay, and then from here, you might want to turn this into mixed fraction so that it is a number that you can recognize. How many 4s can go into 77? Well, how many 4s can go into 7? Only once. Okay, so 4 times 1 is 4. So 7 minus 4 is 37. We're left with 37. How many 4s go into 37? 9 times. And 9 times 4 is 36. So we were starting with 37 minus 36 is 1. We still have 1 of the fraction remaining. So it's going to be 19 over 4 and 1/4. Alright, so then let's try the next one. How is this different to the previous problem? Well, we have a negative sign here. Okay, that means we need to preserve that. It just does not go away. And we also have the variable on the right hand side. Does it really matter? No, it doesn't. Okay, so what's happening to w is that it's being divided by 6. So I need to multiply both sides by 6. Okay, and then this 6 divided by 6, they cancel out to be 1, and you're left with w is equal to, remember 6 is same as 6 over 1, and when you're multiplying fractions, you multiply top with top and bottom with bottom. So 6 times negative 2 is negative 12, divided by 5. Okay, I know that I can't simplify this anymore because there isn't a common multiplier that is divisible to both. But I can turn this into mixed fraction. How many 5s go into 12? 2, and you're left with 2 over 5th and negative 2 over 2/5. Okay, let's try see how is this problem different. Well, the variable is at the bottom. Okay, most common problem that students do is they think, okay, so I want to get rid of this 12, so I'm going to multiply both sides by 12. Then what you end up doing is 12 over p is equal to 4 over 5. And then you multiply both sides by 12. And then you say that p is same as 4 over 5 times 12. Well, that is incorrect. Why? Because 12 times 12 does not become 1. And you have the variable at the bottom. So you really have not brought this to the top. Okay, so this is wrong. Okay, so do not do this, but instead we want to bring the p to the top. How do I do that? We need to multiply both sides by p. Then when you do that, p divided by p, that cancels out, and you are just left with 12 is equal to 4p over 5. And again, I want to get rid of this 5, so I am going to multiply both sides by 5, and this goes away, and you're left with 4p is equal to 12 times 5 is 60, and then 4p divided by, you divide both sides by 4, and you get p is equal to 15. Last question, I'm running out of time, so I'm going to do it really quickly. So I want to get to y is equal to something. So I want to get rid of this 3 and 5. I want to multiply this by 5 to get rid of the denominator 5. And that leaves me with 3y is equal to 4 times 5 is 20 over 9. And then from here, I want to divide both sides by 3. So dividing by both sides by 3 is same as multiplying by a 3, and that leaves me with y is equal to 20 over 20.